Guys, today we're going to talk about type 2 binary ionic compounds. The difference between these and type 1 is these ones involve transition metals, your D block mainly. It can include your F block, and tin and lead, which we'll get to. Different than type 1 because type 1 contains representative metals, which would be your S block and any metals in the P block. Some vocabulary you need to know as we go along. Transition metals, type 2 binary ionic compounds, nomenclature, crystal lattice, electrolyte, precipitate, net charge. Skills you should be able to apply, where you should be able to write the formulas for type 2 binary and write the names for type 2 binary. So those are things to be on the lookout for. All right, before we go further, let's talk about some ionic properties. So these are some properties of all ionic compounds. First of all, their bond formation. It's very important that you know that in an ionic bond, electrons are transferred from a metal to a nonmetal. So they are given from a metal and taken by a nonmetal, okay? We'll be studying a different type of bonding after this in which the electrons are shared. So you want to make sure you understand that they are transferred, so given and taken in ionic. The type of structure that is formed is called a crystal lattice. Up here is a picture. Let me figure out how to do this. Sorry, I'm using this new pad and I don't quite have it down. Okay. So up here, this is a picture of a crystal lattice structure. And what it is that your negative ions surround your positive ions and vice versa, and they form this lattice structure. Okay, this is what salt would look like under a microscope. It looks like a crystal. Okay, so this crystal lattice, what you have here is you have your negative chlorines and you've got your positive sodiums in the blue. So beside each positive sodium, it's going to be surrounded by negative chlorines. Each negative chlorine is going to be surrounded by positive sodiums. And they have ionically bonded to one another, so given and taken electrons. This is a really strong bond, okay? It's hard to break this bond down. Because of that, their physical state will be solids. And let's talk about what that looks like for a second. What happens is if we add two liquids, and we're going to do a lab that's going to show you this too, they're going to form a solid, okay, if it's an ionically bonded compound. So you've got to be familiar with this word. A precipitate, we will use over and over and over, so drill that into your memory right now. A precipitate is not rain that comes from the sky, okay? A precipitate is a solid formed from two liquids. Very important, okay? So ionically bonded compounds are solids. Ooh, I don't know what's going on. Can't control my new pen. Sorry, hang on. I really don't know what's happening. So I'm going to just put that down for right now. Melting point and boiling point are high. It is hard, again, to break down these bonds. So it's hard to melt them or to boil them. So you've got to have a very high temperature to separate those. Soluble in water, yes, they will dissolve in water. An ionically bonded compound will dissolve in water. Think of salt. Salt is an ionic compound. If you put salt in water, it will dissolve, okay? Electrical conductivity. Here's another vocab word you need to know, electrolyte. Ionic compounds will only conduct electricity in a liquid form. If you try to get them to conduct electricity as a solid, it's not going to happen. It has to happen as a liquid, and that's called an electrolyte, okay? So important vocab words you need to know. All right, another very important concept that you have to know is that the net charge of an ionic compound is 0, okay? The reason for this, if you have Al2S3, okay, what that means, That 2, that subscript, is telling you you have 2 atoms of aluminum. All right? Each atom of aluminum has a 3 plus charge using your 1, 2, 3 skip 3, 2, 1 zip. That gives you a total charge with the aluminums of 6 plus. This compound tells you that you have 3 sulfur atoms. Well, each of those 3 sulfur atoms has a negative 2 charge, 1, 2, 3 skip 3, 2, 1 zip. That gives you a total charge for sulfur as 6 minus. So your overall charge for your ionic compound is 0. All right, there's another example down here. If you have Fe and Cl, if you write that formula, you've got Fe 3, apparently, Cl 1 minus. You write your formula using your crisscross, so Fe Cl 3. You look here, each of those 3 Cls has a 1 plus charge. Sorry, I'm getting used to this new pen. It's ugly. So that equals 3 plus total for your Cls, okay? Your Fe, or sorry, I'm so sorry. I just wrote 3 plus and I meant to write 3 minus. Concentrating too much on the pen. Let's try that again. So 3 minus. Oops. So they each have a 1 minus charge. That gives Cls a total of 3 minus. The Fe here has a 3 plus charge, and there's only one of those according to this formula right here. So 3 plus and 3 minus equal 0. Okay, so very important to know the net, which means the overall total charge, what you're left over with, of an ionic compound is 0. All right, let's get into what we're talking about with type 2 binary ionic compounds. Some information. The word nomenclature means naming. Okay, so if I say nomenclature, I mean naming it. You guys studied some nomenclature in biology. You studied binomial nomenclature, and that was the 2-word name for your genus and species, okay, in biology. So nomenclature means naming. Type 2 refers to transition metals. So again, I told you it's different than type 1, which were representative metals. So type 2 are your transition metals. Those are in your D block and your F block. We don't use those very much, so focus on your D block. Transition metals don't have a definite charge like representative metals do. So in your S and P blocks, those are your representative metals. We know it's 1, 2, 3 skip, 3, 2, 1 zip, okay? But in your D block, your transition metals can change. So their charge is shown as Roman numerals in parentheses. If you do not know your Roman numerals, make sure you memorize these. That 1 is a 1, then you've got 2, 3, 4, and 5, okay? So know your Roman numerals. Those are the only ones you need to know. We very rarely use 5, but just in case it pops up. So the same transition metal can have multiple charges. For example, you can have lead 2 with a 2 plus charge or lead 4 with a 4 plus charge. So that's why they're transition. They transition from one charge to another. So there has to be a way for you to know what the charge is, so that's where those Roman numerals come in. Here's something really important. You have to memorize these two. Tin is a transition metal. It is not in the D block. It's over in the P block. Lead is also a transition metal, okay? It's in the P block too. So these are exceptions. Chemistry is full of exceptions. So you need to know your transition metals are in the D block and F block, and also tin and lead. So memorize those immediately. Tin and lead are included in the transition metals. All right, let's talk about writing binary ionic type 2 formulas. We're going to use the crisscross method again. Okay, so you've already used that. You know how that works. We're going to show our work, then we're going to write our formula. The charge of the cation, which is your transition metal, your positive metal, is the Roman numeral that is in parentheses. So, for example, right here, tells us the charge on that chromium. So what we have there is we have chromium, and since it's a transition metal, we can't be sure of its charge. That 2 is telling us that it has a 2+ charge, okay? Fluorine is your nonmetal, and it's a representative nonmetal, so we know that its charge is 1 negative from our rhyme. After that, all you have to do is crisscross your charges. So the 1 comes down after chromium, but you know we don't write down a 1. And then after fluorine, that 2 comes down here. So that is our formula for chromium 2 fluoride. So we brought the 2 down here. Okay, the 1 would come down here, but we don't show a 1. All right, let's look at the next one, cobalt 2 oxide. All right, so we have cobalt, and it's telling us the charge on that cobalt is 2. And it's a metal, so we know it's a positive charge. Then we have oxygen, which is a representative nonmetal, so we know from our rhyme it's 2-. And what happens if you have a 2+ and a 2-? They simply are going to cancel each other out. So because if you bring them both down, you can simplify them. So we're simply going to have COO as our formula for cobalt 2 oxide. Let's look at cobalt 2 chloride. All right, so we have our cobalt again with a 2 charge. And then we have chlorine, which we know has a 1 negative charge. So crisscross as always, so we're going to have COCl2 as our formula. And then let's look at lead 4 oxide. This one's a little different because we have that charge of 4, which we haven't seen in type 1. So we have lead, which again is not in the D block, but is a transition metal. And it says lead's charge is 4. And we know it's positive because it's a metal. Then we have oxygen, which has a 2- charge. All right, so what we can do here before we even crisscross, well, let's just crisscross first. Let's crisscross. So we get Pb2O4. Now here's the deal. When you have a 2 and a 4, you have to simplify or you're going to be incorrect, okay? If you wrote that as your formula, I would have to mark you incorrect. So we have to simplify this or reduce it. So we know that 2 goes into 2 once and 2 goes into 4 2 times. So what our real formula is PbO2. So make sure you reduce if you have a 2 and a 4. Okay, same would happen if you had a 3 and a 6, but we probably won't run into that in here at all. So this is how you write type 2 binary ionic compound formulas. Again, your charge is the Roman numeral. All right, don't get that confused. That is your charge for your transition metal. Your nonmetals charges are still from the rhyme. Now let's talk about naming. This is where it gets a little bit more complicated, so pay really close attention. You have to use the charge of the anion to find the charge of the transition metal here, because we don't have a Roman numeral. We're going to have to write a Roman numeral. We're going to have to kind of work backwards or add up the charges. I'll show you kind of both ways. You're going to name the cation the transition metal. So in this case, for the first one, we know Fe is iron. And we're going to have to write its charge in parentheses as a Roman numeral. So we don't know that yet, so I'm going to just put the parentheses there. And then we're going to write the name of the anion, change the ending to "ide," just like before. So it's chloride. So what we have to figure out here is we have to figure out that number that should be in here, the charge on iron. So what you can do is you know that you have Fe and you have 3 Cls according to the formula. Okay, 3 Cls, 1 Fe. Well, we know each Cl has a charge of 1+. All right, that gives, why do I keep putting plus? I am so sorry. HCl has a charge of 1 minus. Okay, so that gives us a 3 minus charge overall. And what did we say the net charge of any ionic compound is? It's 0. So we know that the charge of the Fe has to be 3 plus. And since there's only one Fe, it's got to go to it. So we found out that Fe's charge is 3. That's what we're going to put in Roman numerals here. That's probably the best way for me to show you this. I'm going to stick with that, and if you guys kind of figure out the other way, and that's fine, but this is the easier, better way for you guys to do this, so I'm going to stick with that, so not to confuse anyone. All right, let's look at PbO. Okay, so we know that Pb is lead. We're going to have to find what goes in parentheses here. It's Roman numeral, it's charge, and we know that's oxide. So we've got to solve the mystery of what goes in the parentheses. Now, you are going to be tempted to put a 1 because there are no numbers here. Don't do that. Think it through, okay? So what we have here, according to the formulas, we have 1 lead and we have 1 oxygen. We know the oxygen's charge is 2 negative, okay? So we have a total charge on the negative side of 2 negative. We only have 1 Pb, and we need a 2 plus charge on that side to get a net charge of 0. So its charge had to have been 2 plus. Does that? I hope that makes sense. If not, ask me questions in class or Teams meeting with me or send me an email. Okay, so let's look at MnO2. All right, so we've got Mn is manganese. Don't screw that up with magnesium. A lot of people make that mistake. So Mn is manganese. We've got to figure out its charge and put it in Roman numerals. And O2 is again oxide. So let's take a look at this. We have 1 Mn and we have 2 O's according to the formula. Oxygen has a charge of 2 minus. Each oxygen does. That gives us a 4 minus charge. Well, our total positive charge to bring this to 0 has to be 4 plus. There's only 1 manganese to put it on, so we're going to have to assume manganese's charge is 4. Okay? And then let's take a look at Cu3P. All right, so we've got copper. Find that charge. And we've got phosphide this time. All right, well, we have 3 coppers here, according to the formula, and we have 1 phosphorus. Well, we know a phosphorus has a 3 minus charge. 1, 2, 3, skip, 3, 2, 1, zip. That gives us a total of 3 minus on this side. Well, that means we have a total of 3 plus that we need on this side. We have 3 coppers, so we're going to have to split that 3 plus up between the 3 coppers. So each of those coppers is going to have a charge of 1 plus. So we'll write copper 1 phosphide. Now, sometimes the 1 is not written. So if you just see copper phosphide, and you know that copper is a transition metal and there is no Roman numeral, you will simply assume that its charge is 1. All right, I hope that makes sense for all you guys. Please let me know if it doesn't, and I will talk to you all soon. Thanks so much for watching.